The first page of Friday's quiz was asking us to find some limits of a function graphically, which basically means you're looking at a function and you're making educated guesses as to what f of x should be as x approaches particular values. This first one, A, is saying what happens as x is approaching negative 2 from the left. Remember, this little superscript negative sign means approaching from the left. And the way that you do that is you go to x equals negative 2, we move a little bit to the left of negative 2, go down to the function, and then just sort of follow it along towards negative 2 and see what the function looks like it's going to be at that point. Now, in this case, it actually equals 0 at negative 2. So this one's really easy, right? The function looks like it's going to equal 0. It actually does equal 0, so the limit is 0. Part B is saying, look at the limit as x is approaching negative 2 again, but this time from the right-hand side. Okay, so what that means is go to negative 2, move a little bit to the right of that, go down to your function, and trace it along this time towards negative 2 from the right-hand side, and see what it looks like it's going to equal. Now in this case there's an open dot at the point negative 2 comma negative 7. So if you're approaching from the right-hand side, it looks like the function is going to equal negative 7 at that point. It doesn't actually equal negative 7, but again, the important thing is what it looks like it's going to equal. Okay. C now is not asking you for a right or left-hand limit. It's just asking you for the limit as x is approaching 0. So you have to actually do the work and look at the left-hand limit, look at the right-hand limit, see what they are, and if they happen to agree, that will be the limit as x approaches 0. Okay, so we can first look from the left at what happens, right? So the way this is written is limit as x is approaching 0 from the left of f of x. And again, that means go to 0, go a little bit to the left, go up to your function, and then follow that along towards 0 and see what it looks like it's going to equal at that point. Well, it looks like, if you follow this along, it looks like it's going to hit 1, and it actually does hit 1. So the limit from the left-hand side equals 1. And if we approach it from the right, we'll find that it's going to be the same thing, right? So that means go to 0, go a little bit to the right, go to your function, follow the graph along towards 0 and see what it looks like it's going to be. And again, it looks like it's going to be 1. Okay, now since these two agree, that means we can conclude that the limit as x approaches 0 of f of x is 1. All right, then we've got two more. Now these two are both asking for the limit as x approaches 2. D is saying from the left, so that amounts to, again, go to x is 2, go a little to the left, go up to your function, follow it along towards 2, and see what it looks like it's going to equal. In this case, we have an open dot at the point 2 comma positive 3. And so that's saying that the limit is going to be 3, right? Because if you're coming from the left, it looks like the function is going to equal 3 at that point. All right, and then the last one is looking at the limit as x approaches 2, but this time from the right. This little plus sign is saying from the right. So we go to positive 2 on the x-axis, move a little to the right, down to the function, follow it along towards 2, and see what it looks like it's going to equal. In this case, there's a closed dot at the point 2 comma negative 2, which means that the limit is negative 2. Problem number 2 is asking us to find some limits algebraically, and what we're going to do is use the fact that we know the limit of f of x as x goes to 0, and we know the limit of g of x as x goes to 0, in conjunction with the properties and limits that we have, to basically break the limits apart that we're trying to solve, and then apply these two facts to get numerical answers. So for part A, we have the limit as x goes to 0 of some stuff divided by some other stuff. And we know that so long as the bottom doesn't go to 0, we can split it into the limit of the top divided by the limit of the bottom. And that's exactly what we're going to do, because we have f times g in the bottom. We know that those limits aren't going to give us 0 when we multiply them together. So on top we've got the limit as x goes to 0 of f of x minus g of x all cubed. In the denominator, we've got the limit as x goes to 0 of f of x times g of x. Using the fact that if I'm raising the thing inside the limit to a power, I can bring that power outside the limit. The top is going to become the limit as x goes to 0 of f of x minus g of x. And then we're going to raise that whole limit to the third power. So we're going to take the limit first and then raise it to the third. And then in the denominator, we've got a product inside the limit, and we know that we can take that and split it into the product of the limits. So we've got something like that. All right, now we can just kind of go ahead and apply these limits, right? We know that up here, since we've got the limit of something minus another thing, it's the limit of the first minus the limit of the second, right? So up top, we've got the limit of f, which is minus 3, minus the limit of g, which is 2, all raised to the third power. And then in the bottom, we've got the limit of f, which is negative 3, times the limit of g, which is 2. All right, and just doing a little bit of the arithmetic here, the top's going to be negative 5 cubed, the bottom's negative 6, and negative 5 cubed is negative 125. So we're going to have negative over negative, which is positive 125 over positive 6. All right. B, there's a little bit less work to do. In B, we've got the limit of the square root of some things, right? And again, using the property that exponentiation inside the limit can come outside the limit, we can turn this into the square root of the limit as x goes to 0 of 2 minus g of x. All right, now the limit of 2 minus g of x is easy to do, right? Because it's the difference of two limits. If you want to write it out, it's the limit of 2 as x goes to 0 minus the limit of g as x goes to 0. And, well, the limit of any constant is just the constant itself. The limit of g we know is positive 2, so we've got the square root of 2 minus 2, which is the square root of 0, which is just 0. For problem number 3, we're taking the limit as x is approaching negative 2. And our goal is to be able to find that limit by just plugging in negative 2. But as the problem is stated, we can't do that, right? Because the denominator is x plus 2, and if you plugged in negative 2, you would have division by 0, which we can't do. So the goal is to first simplify the thing inside the limit and then see if maybe we can get it to the point that we could plug negative 2 in. Now, in this case, the top we can factor. So the top we can rewrite as x plus 2, x minus 2, and the denominator is just x plus 2. And so the x plus 2 terms are going to cancel out, right? And we'll be left with something a little bit simpler to work with. So we'll be left with the limit of just x minus 2 as x is approaching negative 2. And now we can just plug negative 2 in, right? What this becomes is minus 2 minus 2, which is negative 4. Okay, one thing that I do want to emphasize is that remember that the limit, this whole limit notation out front, is basically an operation that you're doing. And so once you take the limit, which in this case was plugging in negative 2, you get rid of the symbol out front. You get rid of the limit as x approaches negative 2 because you've done that in this step. Okay, and then it's just a matter of doing the algebra. All right, number 4 is a limit now as x goes to infinity. And it's the limit as x goes to infinity of a rational function. So what we do is we divide everything by x to whatever the highest power of x is in the rational function. In this case, it's x to the 4th. And so this is going to become the limit as x goes to infinity. Let me just write this out first. So we're dividing both the top and the bottom by x to the 4th, or that's equivalent to multiplying by 1 over x to the 4th, right, of all this stuff. Okay, now once you multiply that through and simplify a little bit, what you're left with is the limit as x goes to infinity. Alright, this first term's got an x squared, so when you do that multiplication you'll end up with just an x squared in the denominator. Here this is 7x to the fourth, so that's just going to become 7. And then on the bottom we're going to have 9 over x squared minus 5 over x cubed minus 6 over x to the fourth. Okay, and now what we're going to do is we're going to take the limit of each of these individual terms and then add them together and divide and all that kind of stuff. So if you look at this first term here, as x goes to infinity, this thing goes to 0, right? And again, since I'm taking the limit, I'm going to stop writing the limit symbol. The limit of 7 is just 7. The limit of 9 over x squared is 0. The limit of 5 over x cubed is 0. The limit of x 6 over x to the positive fourth is 0. So what we end up with is negative 7 over 0. And we know that that can never happen, right? We can't have that. So what we conclude is that the limit does not exist.